Let's start off with a right angled triangle. The length of one side is 3 and the length of the other side is 4. The question is, what is the length of the hypotenuse? Now we can use Pythagoras Theorem in order to work this out. Now before we work through a motivation for a proof, we're going to just give you the answer. Afterwards we will show that this is correct. So Pythagoras Theorem tells us that if we have a right angled triangle, then the sum of the squares of the two sides is equal to the square of the third side. So if we call this side A and we call this side B, then the third side here we can call C. So we can say that A squared plus B squared will equal C squared. So in this instance here we can say that A is equal to 3 and B is equal to 4 and C is equal to the side that we're wanting to work out. So 3 squared is 9 plus 4 squared is 16. So 9 plus 16 is 25. So C squared is equal to 25. So C is equal to the root of 25 and the root of 25 is 5. So by Pythagoras, this length here should be a length of 5. And this would give us a 3, 4, 5 triangle. Now this only works for right angled triangles. So let's have a little look at the motivation towards a proof of this and see why it is that it works. So let's start off by squaring this side. Whenever we square something, we multiply it by itself. So we're going to multiply 3 by 3 to give us 9. So whenever we do this, we're going to end up with a square which has got length 3 and length 3. So the overall area of this little square will be 3 times 3, which is 9. Now we'll do the same for the other side. So we're going to have 4 by 4, and this will give us a square of area 16. Now if we were to take this other side here, now we know that the length of this side now is 5. So if we square this side, we're going to have another square here, and the area of this should be 5 by 5, which is 25. So that means that this area here is equal to this area here plus this area here. So we should be able to place this square inside here and also this square inside here and have nothing left over. So let's go ahead and we'll do that now. So we've taken this square here, which is 4 by 4, and we've placed it inside the large blue square. Now we've got this area left over. So if Pythagoras theorem is correct, the area that's left over here should be this area here. So what we can do is we can split this into 3 little strips, and we can place these strips inside this section here. So I can take one of them and I can place it in here, and then I can take the other 2, I can place one here, and I can place the third one here. So you can see that this area here is in fact 3, because we're going to have an area of 1 block here, and 1 block here, and 1 block here. So this shows us graphically how Pythagoras theorem works. If we have a right angled triangle, and we take the 2 shorter sides of the triangle and we square them and add them, then this will give us the length of the longest side of the triangle squared. And you can see that by creating the square here for this side, creating the square for this side, and creating the square for this side. And then placing this square and this square into the large square. Now this is not an actual proof of Pythagoras theorem, because it shows that it works, but only for this one particular example of a right angled triangle, which is 3 by 4. We want to show that it works for every right angled triangle, and we'll do that on the next video.